Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss self-inductance and energy stored in a magnetic field. Let's begin. Self-inductance. Self-induction is the property of the coil due to which an opposing EMF is induced across it due to the change of magnetic flux through that of same coil by means of varying current flowing through it. As current vary, current produces magnetic field, so variation of magnetic field creates the change of magnetic flux. Look here, here we take the coil, current I flow. If the current is in increasing form, from 0 to maximum in a coil, then the induced EMF is against the current, the direction of induced EMF. Again, if the current in that coil decreasing from maximum to 0, then the induced EMF in the direction of the current okay. So, the phenomenon according to which an induced EMF or current is produced when changing current is passed through that coil is called self induction. Here we found that the magnetic flux linked through the coil is proportional to the current flowing through that of coil. Look here, the magnetic flux that is phi linked through the coil is proportional to the current I flowing through it. That is the magnetic flux linked through that of coil, total magnetic flux directly proportional to the current passing through that of coil I. Here we use the proportionality constant L I, where L is known as the coefficient of self induction, that is the coefficient of self induction, or simply we can say, or that is the self inductance of the coil, self inductance of the coil. Look here, that self inductance of that of coil depend upon which factors? That self inductance of the coil depends on the number of turns of the coil. If there are n number of turns of that of coil, so the total flux be increased like that of n phi. The self inductance depend upon the number of turns of the coil. If the number of turns of the coil increases, then accordingly the magnetic flux linked through that of coil also increases. Again, the area of cross section of the coil. If the area of cross section of that of coil increases, then the magnetic lines of force linked to that of area of the cross section also increase. That indicates the magnetic flux also increases. Area of cross section of the coil, and also the nature of the material of core on which coil is wound. If that core is the material like conductor, insulator or any kind of dielectrics, then that depend upon the self inductance. So, the nature of material of core on which coil is wound. Self inductance depend upon these points. So, the coefficient of self inductance or self induction of the coil is numerically equal to the total magnetic flux linked with it when the unit current is passed through it. L is equal to phi by I. Now, we substitute that value in case of Faraday's second law of electromagnetic induction. From Faraday's second law of electromagnetic induction, induced EMF E is equal to minus d phi by dt. That is the induced EMF, or E is equal to minus d by dt Li, or E is equal to minus L di by dt. Look here, what should be the unity of that self inductance here? If di by dt is equal to 1, if di by dt is equal to 1, then E is equal to minus L means induced EMF is equal to self inductance of the coil. Hence, we define the self inductance of the coil, the self inductance of the coil is numerically equal to the EMF induced in the coil, the EMF induced in the coil when the rate of change of current is unity, when the rate of change of current is unity. In this way, we define self inductance of that coil. Now, the unit of self inductance, unit of self inductance that is in SI, the unit is Henry. If E is equal to 1 volt and di by dt, rate of change of that current be 1 ampere unity, then the self inductance L is equal to 1 Henry. In this way, we define 1 Henry. Thus, definition of 1 Henry, the coefficient of self inductance, the coefficient of self inductance is said to be 1 Henry. If an induced EMF is 1 volt, if an induced EMF is 1 volt is produced in a circuit when the current changes is 1 ampere. When current changes at the rate of 1 ampere per second, rate of 1 ampere per second, that be the definition of 1 Henry, that is the definition of 1 Henry. Okay. So, here we discuss the phenomenon of self inductance, its mathematical equation, unit of self inductance and definition of 1 Henry. Now, energy stored in a magnetic field, energy stored in a magnetic field. How we calculate energy stored in a magnetic field? Look here, the magnitude of induced EMF due to the rate of growth of current, the magnitude of induced EMF due to rate of growth of current rate of growth of current, as E is equal to induced EMF, its magnitude, that is L di by dt. We derive that equation here, E is equal to minus L di by dt. If we take the magnitude, then it will be L di by dt. Again we know EMF is defined as the amount of work done per unit charge. Know that EMF is defined as the amount of work done per unit charge. That is E is equal to, let amount of work done dW, take that of unit charge, dq. Hence from 1 and 2, from equation 1 and 2, we get dW by dq is equal to L di by dt, or dW is equal to L dq by dt into di, dq by dt, that is the current, rate of change of charge, that is dW is equal to L I di. Now the total work done in increasing the current from 0 to maximum, let the maximum value of current be the I naught. Here we take, therefore the total work done in increasing the current from 0 to maximum value, let I naught, maximum I naught is obtained by integrating that one. So W is equal to integration from L I di, change in current from 0 to I naught, as we take the growth of current di by dt from 0 to I naught with the maximum value, or W is equal to L, that is I square by 2 using limit 0 to I naught. So we have W is equal to half L I naught square. That amount of work done in increasing the current from 0 to its maximum is used to store that magnetic energy. So the work done increasing the current flowing energy U of that of magnetic field, we can say, thus energy stored in a magnetic field is U is equal to W, that is U is equal to half L I naught square, that is the energy stored in case of a magnetic field. Let here we take an example as solenoid. For solenoid, we have to calculate what should be the energy stored in case of magnetic field of solenoid. Look here, if we consider a solenoid means a tightly wound coil of insulated wire which possesses an appreciable self inductance, then that is known as the inductance coil or simply as inductor. So, this is the inductance coil or a inductor L. Here we consider an ideal inductor which has very high value of self inductance and 0 ohmic resistance. So, we consider a circuit consisting of inductance coil along with a battery with a key on pressing the key K, the circuit current I flows and the phenomenon of self induction opposes the growth of current in that of circuit. During this opposition, some work is being done in increasing the current from 0 to maximum against that induced EMF, and this work which is stored as the magnetic potential energy in case of inductor, that energy stored in case of magnetic field. Okay. Here we have to calculate the energy stored in case of magnetic field, that is calculate self inductance of that coil. Look here, let small l be the length of that of inductor, small l length of that inductor or that is a solenoid, that inductor. We can see that is a solenoid. Here the medium be air, vacuum medium, and small n with the number of turns per unit length, A with the area of cross section, area of cross section of that solenoid. Therefore, the total magnetic flux linked with that solenoid, therefore, total magnetic flux linked with that solenoid is equal to total magnetic flux linked with that of solenoid with the total number of turns, that is the total number of turns into flux through each turn, flux through each turn. Look here, let the total flux linked with that of solenoid be phi. total number of turns. Here n be the number of turns per unit length, L be the total length. So the total number of turns be total number of turns of that of inductor, small l into L. Okay. Now flux through each turn, let B be the magnetic field inside that long solenoid, magnetic field inside that solenoid. So magnetic field inside the solenoid, if the permeability of that free space mu naught, since the medium is air, mu naught, that is the number of turns per unit length, small l, into current flowing through that of circuit, mu naught Ni. Okay, with the magnetic field inside that of solenoid. So the flux through that of each turn is B into A, that is B into area of cross section. B, magnetic field inside that solenoid into area of the cross section. So flux through that each turn, flux, the magnetic field into area. Therefore phi is equal to N L. In case of B, we substitute mu naught Ni into area of that of A, or phi is equal to mu naught N square A L I, that is the magnetic flux linked with the solenoid. If L is the self inductance of the coil, look here, if L be the self inductance of the coil, then total flux through that of coil is equal to self inductance into current I. Here equation number 1, that is equation number 2. From 1 and 2, from 1 and 2, from equation 1 and 2, we get Li is equal to mu naught N square A L I. Therefore I cancel out. So L is equal to mu naught N square A into L, at the self inductance of the solenoid or self inductance of that of inductor. Now the energy stored in case of that self inductor, therefore U is equal to half, place of L we substitute mu naught N square A L into I naught square. I naught square be the maximum current. Look here, look here, here magnetic field in that of solenoid B is equal to mu naught n I naught with the maximum current, or I naught is equal to B divided by mu naught into n, that is the value of L into I square, I naught square, the value of I naught, that is B divided by mu naught n square. Under simplification we have U is equal to 1 by 2 mu naught B square A into L, that is U. Now the potential energy per unit volume, therefore magnetic energy density, magnetic energy density, that is Um, which is the potential energy per unit volume, potential energy U per unit volume, that is area into length. So we have mu naught B square AL divided by AL. Under cancellation we have half B square divided by mu naught. Therefore magnetic energy density Um is equal to half B square divided by mu naught. That is the energy stored in case of solenoid, the energy stored. That is the magnetic energy density, potential energy per unit volume, that for solenoid. So with the help of this video lecture we understand the phenomenon of self inductance, its mathematical formulation, definition of 1 Henry, energy stored in a magnetic field, for solenoid it is self inductance of solenoid, the energy stored in that of solenoid, and magnetic energy density of that of solenoid. So with this useful and informative notes, let me wind up the session. Thank you.